Welcome friends, welcome to the lecture series on engineering graphics. I am Dr. Shivraj Narayan, Professor of Mechanical Engineering, VNR, VJEC. Our today's topic is on scales, one of the interesting topics in engineering graphics. As part of this session, we are going to learn about the concept of scales that are used in engineering and their types, as well as how to construct these scales using AutoCAD software. So first of all, we should understand the concept of scales. What we know is each and every product that is existing has to be manufactured. As far as engineering products are considered, they need to be manufactured. And these products, they generally come in different shapes and sizes. For example, if you take the case of the tallest building in the world, which is Burj Khalifa, which stands at 828 meters, and if you want to go for the construction of such a tall building, then it is very difficult for us to draw the same building on a real scale, that is 1:1 scale. We can't have a drawing of that size. So that is where the scales come into picture. We need to have a scale which will reduce the size of that object on a piece of paper. So whatever products we manufacture, they generally go to the shop floor, wherein the operator has to look at a manufacturing drawing and then manufacture it. So these drawings, they are generally on either A4 or A3 size paper. So when we talk about the tallest building, it cannot be prepared on a 1:1 scale. So obviously it has to be reduced. Similarly, if we take the case of smaller parts, the parts like the micro or the nano gears that are used, then such small parts are also very difficult for us to visualize. So in such a case, what we do, we try to maximize the size of that particular object. So there we need to make use of enlarging scale. So the scales is one of the important topic as far as manufacturing is concerned. So what is the technical definition of it? It is nothing but the ratio between the drawing size and the actual size of an object. Technical definition of scale is given as the ratio between the drawing size and the actual size of an object. And this is designated by a term called as representative fraction. In short, it is designated as RF. So this representative fraction is given by the length on the drawing divided by the actual length of the object. That means whatever is the actual or the original length of the object, that we will write in the denominator, and the value that we are going to make use of on paper will be shown in the numerator. The ratio between these is called as representative fraction. So what are the important points that we should remember here? That both numerator and denominator in this ratio, they must be in the same units. You can't have the numerator in centimeters and the denominator in meters. That way it will not work. So once we follow this, both must be in same units, it automatically means that RF has got no units. Now coming to the types of scales, as such we have 5 different types of scales: plane scale, diagonal scale, vernier scale, comparative scale, and scale of chords. So as far as engineering graphics is concerned, the syllabus specifies the first 3 types of scales, that is plane scale, diagonal scale, and vernier scale. So we are going to learn about the concept of these scales as well as its construction. Now before we actually delve into that construction part, the most important point in scales is the knowledge of units of conversions. One has to know the relationship between the conversion of the units. So here we are showing the metric units. So if you want to convert the metric units in the different types of subunits, then we need to remember this. Like from here we have shown, we are moving from millimeters to kilometers. So if you want to move towards the right, that means if you want to move towards centimeter, then we need to divide by 10. Or if you want to make this conversion from centimeters to millimeters, then multiply by 10. So this relationship has to be remembered, and this is a table which shows the different conversions of the metric units. So here you can see 1 centimeter is equal to 10 millimeters. So then 1 decimeter is 100 millimeters. So all the values are shown in millimeters here. If you want to remember 1-to-1 conversion, then this becomes 1 centimeter is equal to 10 mm, 1 decimeter is equal to 10 centimeters, 1 meter is equal to 10 decimeters. That way you can follow. Now we'll move on to the first type of scale, which is plane scales. So what is the important point? Whenever our requirement is such that we need to show two units. We need to show two units in a drawing, or you want to show a main unit and its subunit, then we generally make use of a scale called as plane scale. It is something similar to our regular scale that we use in our geometrical drawing. So wherein two units are shown, you will have a major unit and its subunit. Example is like showing centimeters and millimeters. Now how do we construct the scale? So the standard steps that we need to follow are shown over here. The first step is we need to calculate the representative fraction. So in certain problems, the representative fraction will already be given to you, and in other type of problems, you will have to calculate it. If it is given, you can directly make use of it. If it is not given, as per the formula, you can calculate it. The formula we have already seen in the earlier slide. The second step says we need to convert the maximum length into its smallest unit. That means we need to do the conversion. The slide that we have just now seen showed the conversion of units. So we need to convert that because we will be making use of different units as such. Then the next step is to find the length of scale, and the length of scale is given by this relationship. Length of scale is representative fraction into maximum actual length. Once we find out the length of scale, then we need to draw a line equal to that length, divide it into main equal divisions, and then divide the first main division into its smaller subunit divisions. So this is a very simple procedure as far as plane scale is concerned. Now we will go through this problem statement on how to construct the plane scale. So what is the statement? A mechanical engineer is preparing a layout drawing of 4 meters long transmission shaft used in a conveyor system. The drawing is to be prepared at a scale of 1:50. A bearing housing is located 2.6 meters from the left end of the shaft. Construct a scale to measure up to 4 meters and mark the position of the bearing housing. So as such, we can see here the unit that is specified is meters. So we have 4 meters as the maximum length or the length of the transmission shaft. 1:50 means this is the scale that is mentioned, so which automatically means the RF is given to you as 1/50. And then they have given a position that we need to show on the scale that it is 2.6 meters. So 2 is meters and the subunit is 0.6 meters. So this is what we need to do. Now, in order to construct the scale, let us see the demonstration in AutoCAD. So first of all, I'll write down the given data. So for that, I'll make use of mtext command. So actual length of shaft is given as 4 meters. Then the next data is scale, that is RF is given as 1/50, and the position of bearing which we need to show on the scale is 2.6 meters. So this is what is the given data. Now if you just go back to the steps that are involved in the construction of plane scales, the very first step says we need to calculate the representative fraction. So in this problem, the representative fraction is already given, so we did not calculate it. The second step says we need to convert the maximum length into its smallest division. So here we have been given 4 meters as the actual length of shaft. So this will convert into millimeters. So 1 meter is nothing but 1000 millimeters. So we'll multiply this by 1000. So this becomes 4000 mm. So this is the second step. The first one is representative fraction, which is already given. Then in the second step, we need to convert this maximum value into the smallest unit. Next, the third step says find out the length of scale. So again, I'll go to mtext command and write down the formula that length of scale is given by RF into maximum actual length. So RF is given as 1/50 and maximum actual length is nothing but this actual length of shaft, which is 4 meters, which we have converted into the smallest unit, that is 4000 mm. So this becomes 80 mm. So what does this 80 mm indicate? That this is what is the length of our scale that we are going to construct, and this 80 mm is going to represent 4 meters length. So now we'll start the construction of this scale. Use line command. See that the ortho is on, and then draw a line of length 80 mm. Now in order to give this scale a representation of a physical scale, we'll try to construct a rectangle. So don't terminate the line command, instead continue it and draw a vertical line of 10 mm. And then repeat line command so that we complete this into a rectangle. So we have drawn the length of scale as 80 mm using line command, then vertical line of 10, and then we have drawn this horizontal and vertical line to complete this rectangle, which will give it a representation of plane scale. Now make use of the divide command and divide this original line into number of parts. Now how many parts we should make? So we have been told in the problem statement that this scale should represent 4 meters length. So this 80 mm line, now it should be divided in such a way that it should represent this 4 meters. So that means we will be dividing it into 4 equal parts, and each part will represent a length of 1 meter. So I'll type 4 and press enter. Now you can see the line has been divided into 4 parts and points are shown over here. Now I'll make use of copy command. Select this line and place it at these points. So now we have completed this scale representation. Now you can see here we are able to see 4 such divisions, and each main division is representing 1 meter. Now what is the next step? The next step is we need to divide the very first division into some number of parts. So what is the number of parts here? So it is nothing but the subdivision. So if the main unit is meters, then we need to go for its subdivision. Now we have been asked to show this 2.6 meters length on the scale. So that means we should be able to show that 0.6 meters also in this scale. So for that purpose, the first main division will be divided into 10 parts. So before we do that, we'll start writing the numbers. So I'll make use of mtext command, and I'll write 0 over here. So this is what something you will have to remember. The end of the first main division is always denoted as 0. Copy this 0 and place it at the remaining divisions. So the important point is always the end of the first division should be marked as 0. Towards its right, whatever are the main divisions, we should number them sequentially. So after 0 it is 1, then 2, and then 3. Next, already I told you that the first main division should be divided into the subunits or the subdivisions. So here now we are going to convert this into the subdivision. So we will divide this line into 10 equal parts. So for that, I'll draw one small line starting from this end to the 0th end. Make use of divide command. Select this line. Enter the number of segments as 10. And now you are able to see 10 such divisions. So the numbering on the first division on the left side of 0 should be like 1, 2, 3 and so on. So I'll double click on the 0 and type it as 10. I'll copy the same and place it at 5th division as well as 6th division. So I'll change this to 5 and the other one as 6. Now make use of the copy command. Select the first line, press enter, define the endpoint of this vertical line as the base point, and start placing these lines on the division points. So what we have done is, we have divided the main length of scale into 4 equal parts. The end of the first division is marked as 0, and towards its right we have marked the main divisions as 1, 2, 3. So these are 1 meter, 2 meter and 3 meter. Now since we need to show that 0.6 meters distance, what we have done is, the first division is now subdivided into its subdivisions. So we have divided the first division into 10 smaller parts. So towards the left of 0 we have started marking 1, 2, 3, 4, 5, 6, 7, 8 up to 10. Next, again make use of line command and draw a line which starts from the midpoint of the vertical line, that is the line starting from 10, until the midpoint of the vertical line starting from 3. Then make use of trim command and start trimming alternate divisions so as to give it a proper plane scale representation. Next, select these horizontal lines. Right click, go to properties, line weight, change the line weight to 0.4. Then we need to show the position of the bearing, which is 2.6 meters. So we can split this into main division and subdivision. So this means 2 meters is the main division and 0.6 meters is the subdivision. So the main division should be counted on the right side of 0 and the subdivision should be counted on the left side of 0. So 2 meters is the main division. So we need to count 0, 1, 2. So up to here it is 2 meters, and the sixth line over here, it indicates 0.6 meters. So the distance between these two lines is nothing but the position of bearing, which is at a distance of 2.6 meters. So now we'll make use of dim linear command. Then show the dimension between these two lines. So by default, the software will measure the realistic distance between these 2 points, because the length of the line is 80 mm. So it will try to measure the distance between these two lines as something within that 80. But this is not we are supposed to show. What we need to show is that this line, it represents 4 meters dimension. So this distance should also represent the distance in meters. So, and that is nothing but 2.6 meters. So now what we need to do is select this dimension, right click, go to properties. Now in the properties, just scroll down. You have this text option, and in the text, the last option is text override, this one. So this is where you can type 2.6 meters. So actual distance is something 52 mm, but we are showing a scale wherein this 80 mm line is representing 4 meters distance. So that's why the distance between these 2 points is also 2.6 meters. Next, we need to show the units. So again, make use of mtext command. So I'm copying one of the already written text over here. Make ortho off. Place it on the right side of the scale, similarly on the left side and the middle. So the right side one should be edited and written as the main unit, which is meters. Similarly, this on the left side, we are writing it as decimeters. And the middle one, this will be written as RF is equal to 1 by 50. So this completes the solution of the given problem. What we have done is, we have constructed a plane scale wherein a 80 mm line is representing 4 meters length, and on this 4 meters line we have represented the position of bearing at 2.6 meters. So what is important here is, we need to be able to find out the length of scale, and this can be done only after converting the major unit into its smallest unit or division. Then we need to divide the length of scale into some number of equal parts as per the given data, and the first main division should be divided into subunits, and afterwards we need to locate the given distance on the scale. So the other important point is it is equally important for us to show the main unit and its subunit and RF as part of this solution. So I hope you have understood this procedure, and I expect that you will be able to solve more problems of plane scales. In the next section, we'll move on to the diagonal scales. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.